Cobweb model analysis with mathematical derivation. Cobweb model framework. The Cobweb model is a dynamic model used in mathematical economics to analyze price fluctuations in markets with lagged adjustments. It's particularly relevant in industries with production cycles, like agriculture, where planting decisions precede harvest by a period. Model assumptions. Demand function. Consumers purchase less as the price increases, represented by a negative coefficient. Supply function. Producers supply more as the price increases, represented by a positive coefficient. Lagged supply. Production decisions are based on prices from the previous period, t-1. Equilibrium. Market equilibrium occurs when quantity demanded, QD, equals quantity supplied, QS. Mathematical representation. 1. Demand function QD of t equals 102p of t, QD of t. Quantity demanded at time t, P of t. Price at time t. 2. Supply function QS of t equals minus 20 plus 4p of t1, QS of t. Quantity supplied at time t, P of t1. Price in the previous period, t1. Equilibrium condition. At equilibrium, demand equals supply. QD of t equals QS of t. 100 to 2p of t equals minus 20 plus 4p of t1. Deriving equilibrium price. 1. Rearrange the equation. 2p of t equals 120 to 4p of t1. 2. Combine like terms. 6p of t equals 1, 2, 0, 3. Solve for p of t equals 20. Cobweb model dynamics. 1. Initial price P0. Choose an initial price, e.g., P0 equals 25. 2. Quantity supplied, Q1. Based on P0, calculate the quantity supplied in the next period, t equals 1, using the lagged supply function. Q1 equals minus 20 plus 4, P0 equals 40. 3. Market disequilibrium. Since Q1 does not equal Q, d of t equals 1, which is 80 for P of t equals 1, equals 25, there's a market disequilibrium. 4. Price adjustment. In the subsequent period, t equals 2, producers adjust production based on the previous period's price, P0. 5. Price fluctuations. This process continues, with prices oscillating around the equilibrium price, P equals 20, until they converge, stable equilibrium, or diverge, unstable equilibrium, depending on the model's stability conditions. Stability analysis. The Cobweb model's stability depends on the relative slopes of the demand and supply curves. We can analyze this using the Cobweb multiplier, derived from the coefficient of P of t1 in the supply function. Cobweb multiplier. In this case, the Cobweb multiplier is d equals 4, coefficient of P of t1 in QS of t. Stability conditions. Stable equilibrium. If d/b less than 1, where b is the coefficient of P of t, in the demand function, here b equals minus 2, the price fluctuations will eventually converge towards the equilibrium price. This requires less than b, which translates to 4 less than minus 2. Not satisfied here. Unstable equilibrium. If d/b greater than 1, price fluctuations will diverge, leading to increasing instability. In our case, since the condition for a stable equilibrium is not met, we have an unstable equilibrium. Solution. Using the Cobweb model with the given equations, the equilibrium price is P equals 20. However, due to the unstable equilibrium, d greater than b, prices will oscillate around this point and not converge. Key points. The Cobweb model provides a simplified framework for understanding price fluctuations with time lags. The model's stability depends on the relative slopes of the demand and supply curves. Real-world markets may exhibit more complex dynamics due to factors like rational expectations and imperfect computation.